So section 5.5 takes us from having an expression to having an equation. So the difference would be if you just solve x squared plus 4x plus 4. Okay, that's an expression. And with an expression, all you can do is factor and simplify it. Today we're going to make it into an equation. When we add in the equal sign, we now can actually solve this equation and get two answers. When we get our two answers, just to give you an idea of what this represents in terms of the graph, okay, remember, a quadratic makes a parabola of some sort. The two answers are going to be representing what are called the zeros of the function. So it's where the parabola crosses the x-axis. And I think we learn this term technically tomorrow, but they're called zeros. And those are the solutions to a quadratic equation. And that's what we're going to be doing today. So basically we're going to be solving by factoring. We're also going to solve by square rooting today. And then tomorrow we'll look at the graphics. So we'll make sure we have our graphing calculators tomorrow. So standard form, just like we've seen, ax squared plus bx plus c, but it has to be set equal to 0 in order for it to be in standard form. So if it's not set equal to 0, you'll have to move some things around using inverse operations. And then we're going to use what's called the zero product property. The zero product property says that if you have two things being multiplied, so if a times b equals 0, so if the product of two things equals 0, then either A has to be 0 or B has to be 0. One of the numbers is 0, that way when you multiply them together, you get 0. Okay, A could be 20 and B could be 0. A could be 0 and B could be 217. Okay, as long as one of those is 0, then therefore the whole expression, when we multiply them, will get you 0. When we're doing it today, it'll be more factored form. So for example, if x plus 2 times x plus 5 equals 0, so we'll see factors like this, binomials, all you're going to do is you're going to set each of them equal to 0. So either x plus 2 equals 0 or x plus 5 equals 0. And then you'll solve each one separately using inverse operations. So subtracting 2 on both sides, one of the answers would be -2. Subtracting 5 on both sides, the other answer would be x equals -5. So today, when we're doing these, our final answer is not going to be this. Our final answer will be two solutions, x equals something. Okay. We should typically get two zeros. There is the chance that we could get one zero twice, okay, and that would be if the graph comes down and touches just at one point and turns back around. And if you do that, you'll end up getting like the same number 2 times. All right, so steps to solve these things. First, we're going to get this in standard form. Which means we want this set equal to 0. We're going to factor. Just like we did before break. And we'll get it to look something like this. And then we'll use the zero product property. Which is basically setting each binomial equal to 0 and solving for x to get our two answers. Now there is a chance you could get 3 answers, and that would happen if it were an x cubed function, and we could take a GCF out. There's a chance you could get 3 answers, but you'll notice that the degree of the polynomial is going to tell you how many solutions you should get. All right, example 1, 1a. First of all, this is not in standard form, so the first thing we would want to do is get it set equal to 0, so we'll subtract 18 on both sides. Then we're going to factor the polynomial down into two binomials. This is an easy factoring because we can see that a is 1. So that means that this is just going to be 1x and 1x. Remember, if this were a 2 or a 3 or a 5, we would then have to do guess and check by checking with our FOILing. We need two numbers that multiply to be 18, negative 18, and add to be 7. So that's going to be 9 and 2, and we'll have a positive 9 and a negative 2. 9 minus 2 will get me a positive 7. Now, before break, that was all we did. We just factored. Now we're taking it an extra step. So since we want to solve this, we're going to set each of these equal to 0. So we'll have x plus 9 is 0, or x minus 2 is 0. Most of you will pick up on the pattern. It ends up being the opposite sign as what you see. But sometimes it does take more solving. If this were like a 2x, you'd have to subtract 9 and divide by 2. But using inverse operations, subtracting 9, we'll get x equals negative 9. And adding 2, we'll get x equals 2. So those are our two answers. Next one, same thing, we have to get it set equal to 0 first, so we'll add 12 to both sides. You cannot factor it until it's set equal to 0. This is also an easy factoring. What would this factor down into? We have two binomials. Yeah?
X minus 1 times x minus 12.
Good. X minus 1 and x minus 12. And then we use our zero product property. Now you'll be surprised, a lot of you on your quiz Friday, you'll turn it in and like you'll leave your answer like this. And then like on all of them. And then whenever you turn it in, usually I'll glance at it and I'll say, Susie, come on back up. Didn't solve these. I'll give it back to you. So you want to make sure you know the difference between if it were to say factor, that's factoring. If it says solve or it has an equal sign, you should be getting two answers. X equals 12 and x equals 1. Just setting each of those equal to 0 and using inverse operations. Add 12, add 1. All right, these are our harder factoring questions. Actually, no. C is not going to be that hard. If you take a GCF out, it will make it an easy factoring problem. So for this one, again, we'll subtract 6 to get it in standard form. If you remember from our notes before break, step 1 was always look for a GCF if possible. Some of you will forget that, and that's okay. You'll still get the same two answers if you forget it. But the factoring would be harder because it's more guess and check. We should be able to take out a factor of 2 here. And that'll get me x squared plus 2x minus 3. And then we can factor that down in an easy fashion instead of having to do guess and check. The 2 just stays up front. So two numbers that multiply to be negative 3 and add to be 2 would be a positive 3 and a negative 1. 3 minus 1 is 2. Now, when you use the zero product property, every year some students ask me, what happens with the 2? Well, if you're using the zero product property, technically you're setting each thing equal to 0. So you'd be saying like 2 equals 0, which we know 2 doesn't equal 0. So that's not going to get me an answer. It kind of just disappears. But technically that's what you would do and then be like, oh, well, this isn't solvable. We'll do each of the other ones. X plus 3 equals 0, x minus 1 equals 0, and solve out to get our two answers, which should be negative 3 and positive 1. See if you guys can try D, which means I am probably going to have two negatives here. So you just kind of have to guess and check until you find the right pair that works. If you use mental notes to look and see what will FOIL in there, the 3 should go here, because that's going to get me a negative 6. And then the 5 should go here, that'll get me a negative 5, and negative 5 and negative 6 gets me negative 11. Now be careful when you actually solve this. Do not tell me that the answers are 5 and 3. Okay, you should be setting each of these equal to 0. So this one actually has 2 steps in order to solve for the 0. You'd have to add 5 and divide by 2. So one of our answers is 5 halves, or 2.5. The other one is, of course, 3. So just don't think that it's always just the opposite. If there's a number in front of the x, you also have to divide by that term. But if you're able to do this part mentally, I don't require you to show the work for it, especially in an honors class. So again, if this problem, when you went to factor it on your own, you had trouble with it, you need to practice factoring more. You're going to do so in the homework because you're going to be factoring and then solving. But there's tons of extra practice on my teacher page. Tomorrow we'll be doing minute math with factoring. So do you remember in elementary school when they'd see like how many math you could do in 1 minute? We're going to see how many things you can factor in 1 minute. Probably give a bonus to the winner. Whoever gets the most factored in 1 minute. But I will be expecting like a certain minimum number. I haven't decided what it will be yet. Some time is. We'll be doing that tomorrow. So practice your factoring tonight. All right. Last type we're going to look at today is solving quadratics by finding square roots. Now, this method only works when you're missing the bx term. So when there is like a 0x. So it'll look like this format, or it could also look like this. Okay, one of those two formats, but you're still missing the bx term. You have nothing with just an x attached. Okay. So when you're solving this, you want to rewrite it into this format. ax squared equals c. And you're going to isolate the x squared by dividing by a. And then you're going to solve for x by taking a positive and a negative square root. I don't know how many of you will forget the plus or minus, but about half of you. You want to make sure that, for example, let's say we got x squared equals 25. If you were solving for x, you take the square root, that's how you undo a square. You have to remember that technically the square root of 25 is positive and negative 5. That's how you're going to get your two answers, which you should have two answers for any quadratic. A lot of you on your quiz will just put 5, and you'll lose a point for missing an answer. So make sure you don't forget your plus or minus. And then we'll simplify if necessary, like if we might have to reduce a radical or something. Okay, so for example 2 down here, we see 5x squared minus 180 equals 0. So this one is missing the bx term, so that means we can solve by square rooting. So we would actually add, and you can still solve by factoring. I should tell you this. If you wanted to, you could take out a GCF of 5 and then factor it as you know how to, but this is just another method you can use. 0 plus 180 is just 180. Again, you cannot square root until the x squared is by itself, so you'll divide by 5 on both sides. To get x squared equals 36. And then we'll square root, again remembering our positive and negative 6. Now some students don't like to write the plus or minus like that. That's a symbol you can write to show both. If you would prefer, and also just to remind yourself, you're welcome to split it up into like 2 separate answers to remind yourself you should have 2 answers so you don't forget your plus or minus sign. I don't care what you do, which one you choose, but you do need 2 answers either represented in one of those fractions. Okay, this one, same thing, we're missing a bx term, so we'll add 25 to both sides. To get 4x squared equals 25. Now, you will divide by 4, but I would not reach for a calculator to divide that 25 fourths. Okay? If you notice, 25 and 4 are both perfect squares. So it's going to be easier, especially without a calculator, to not get decimals and then have to square root a decimal, but to leave it as a fraction. Especially since part of your quiz Friday will be no calculator. So when I divide by that, I'm just going to get, and I'm going to write this up here so Austin can see over my podium. X squared equals 25 fourths. Whenever you square root both sides, you will have to square root the top and the bottom of that fraction. So the square, and don't forget your plus or minus, so I always write that first. Square root of 25 is 5. The square root of 4 is 2. So 5 halves or 2.5. Positive and negative. But again, without a calculator, you probably wouldn't know what the square root of a fraction or decimal would be. Alright. Now, what makes these ones a little bit harder on the back is we may have to reduce the radical. Or rationalize the denominator. So what do you think I would do first for example C to solve for x? 3x squared equals 24. What do I do to both sides to help start solving for x? Actually, good. I see multiplication of 3, so the inverse is to divide. And I'll get x squared equals 8. Now 8 is not a perfect square, so whenever I go and square root this, okay, this is not a perfect square. So what we're going to be needing to do is reduce the radical, which you should have learned this in Algebra 1. We're going to reduce this by breaking it into two factors that multiply to 8. One of them has to be a perfect square. So if you remember, your perfect squares are 1, 4, 9, 16, 25, 36, and so on. All I did was 2 times 2, 3 times 3, 4 times 4, 5 times 5. Okay, so whenever I break this number down, of course, still using my plus or minus in the front, I'm going to break it into 4 times 2. 4 is a perfect square. I like to put my perfect square first when I'm doing this. And your teacher and everyone may have taught it differently than I. And you're welcome to do it that way, but I like to break it into 2 square roots that multiply back to get me my number. Then we take the square root of the perfect square. The square root of 4 is 2. When you take the square root, it's like a coupon. The number gets reduced, and then there's no longer a square root. Okay? You don't get the coupon back to use again and again and again. You only use the square root once. It becomes an outside number, so this will become 2 square roots of 2, or 2 root 2, however you prefer to say it. We do still need our plus or minus in the front. So plus or minus 2 square roots of 2. Okay, D, we're going to have a similar problem here. We will, first of all, add 1/2 to both sides. And then we're going to square root both sides. As soon as we insert a square root symbol, that's when we need our plus or minus. And for this one, I'm going to go ahead, since it's a fraction, I'm going to break it into 2 square roots. The square root of 1 over the square root of 2. Now, at this point, we have a square root in the denominator. We're not allowed to keep that as a rule. Okay, so we might write that down. No square roots in the denominator. So what we're going to have to do is rationalize the denominator. Again, you should have learned in Algebra 1, but we might forget it. Does anyone remember how to rationalize the denominator? How to move the square root from the denominator to the numerator? Hannah?
Multiply this by the square root of 1 on the top and the bottom.
Other way. Multiply by the square root of 2 on the top and bottom. Okay. So to rationalize the denominator, all you do is you multiply by the denominator in both the numerator and denominator. And that's going to get rid of the square root. So in the denominator, we see the square root of 2. So all I'm going to do is multiply by the square root of 2. Whatever you do to the bottom, you have to do to the top as well. Just like if we had 1/2 and 2/4, like those are equivalent fractions. So what happens, square root of 1 times the square root of 2 is the square root of 2. In the denominator, the square root of 2 times the square root of 2 would be the square root of 4. And the square root of 4 is 2. So the whole reason that we do this, rationalizing, is that the square root ends up going away. You're just left with what number is underneath there. So my final answer here should be positive or negative square root of 2 over 2. Alright, the closure just has some more practice problems. I want you to actually go ahead and work on those either independently or with a partner. And there's 6 for you to do. Again, make sure that you have 2 answers for each of them. And whenever you're finished with them, if you want to move around and work with a friend,